Hello everyone. Today we are going to discuss interference and interference due to thin film. After watching this video, students will be able to define principle of superposition of waves, explain interference due to division of amplitude and division of wavefront, and obtain conditions for dark in thin film interference. So you have already studied Young's double slit experiment. When the plane wavefront incident on a slit, okay, and then it passes through two slits. Now here at these two slits there is a division of wavefront takes place. That means one wavefront gets divided into two wavefronts and then these two wavefronts they get interfere with each other. म्हणजे इथं एका वेव्हफ्रंटचं दोन वेव्हफ्रंट मध्ये डिव्हिजन झालं आणि मग त्याचा इंटरफरन्स आपल्याला मिळतो इन द फॉर्म ऑफ अल्टरनेट ब्राइट अँड डार्क फ्रिंजेस. So this Young's double slit experiment is the example for interference due to division of wavefront. So basically what is interference? Interference is nothing but the superposition of two or more than two waves. Now what is superposition principle? If two waves they get superposed with each other, they get mixed with each other. Suppose this is one wave and this is the second wave. आता जर तुम्ही ह्या दोन वेव्ह बघितल्या, they are in phase with each other. So resultant amplitude is the vector sum of these two waves. Now vector sum म्हणजे काय? तर इथं they are in phase, so their amplitude they will get added and the resultant amplitude will be on the higher side. So this type of interference is known as constructive interference. Whereas in second type, if this is one wave and second wave is completely out of phase, म्हणजे ही वेव आणि ही वेव जर आपण बघितली तर त्याच्यामधला फेज डिफरन्स जो आहे तो 180 डिग्री आहे. सो दे आर आउट ऑफ फेज विथ ईच अदर अँड नाउ वेक्टर सम इज व्हॉट, ही जी अँप्लिट्यूड असेल त्याच्यामधून ही सेकंड वेव्हची अँप्लिट्यूड इथं सबट्रॅक्ट होईल अँड देन रिझल्टंट अँप्लिट्यूड विल बी लोअर दॅन द अँप्लिट्यूड ऑफ one wave. Okay, so here this type of interference is known as destructive interference. Now let's see interference due to thin film. What is thin film? Thin film means a layer whose thickness is less than 1 micrometer. म्हणजे एक लेयर असेल ज्याचा thickness 1 micrometer पेक्षा पण कमी असायला पाहिजे. That layer is known as thin film. Now suppose this is a thin film with thickness of course less than 1 micrometer. This is the top surface of thin film. This is the bottom surface of thin film. Now when light ray incident on this thin film, we know when the light ray incident on any medium, it gets partially reflected and partially refracted. Same happens here. AB is the incident ray. It gets refracted along BC in the thin film and reflected along BE. At point C again, it gets partially reflected and partially refracted. So the ray gets reflected along CD and refracted here. At point D again it gets partially refracted and partially reflected. So DI is the refracted ray here. So here BE and DI they are parallel. हे दोन रेज जे आहेत ते पॅरलल आहेत. But the path traveled by this ray BE and DI is not the same. DI ray ला BC plus CD एवढा path travel करावा लागतो आणि ह्या BE ray ला सुद्धा extra path difference travel करावा लागतो. So in order to find out this extra path difference, we have to draw normal. So this normal is say normal GD. आता ह्या GE आणि DI हे जर दोन पॅरलल रे आपण बघितले तर दोघांचाही पाथ जो आहे दे आर पॅरलल. ओके, आणि ह्या जीई ह्या रेला बीजी हा एक्स्ट्रा पाथ ट्रॅव्हल करावा लागतो. ओके, सो दिस इज द एक्झाम्पल ऑफ इंटरफरन्स ड्यू टू thin film. Now this interference, this ray BE and DI, they will get interfere with each other and you are going to see the interference pattern. So this interference obtained due to thin film, is it example of division of wavefront or is it example of division of amplitude? You can pause the video for a minute and you can write the answer. Okay, I hope you have written the answer. Here what happened? Incident ray is there, it gets reflected and refracted. So here what happened? Amplitude, division of amplitude takes place. Okay, division of amplitude takes place. So this is the example of division of amplitude, and Young's double slit experiment, it is example of division of wavefront. Now let's find out the equation for interference due to thin film. Again the same, AB incident ray, BC refracted ray, BE reflected ray. Again at point C, CD is the refracted ray. From point D, DI is the refracted ray. आता ह्या दोन्ही मधला पाथ डिफरन्स जर आपल्याला फाइंड आउट करायचा असेल तर आपल्याला नॉर्मल्स ड्रॉ करावे लागतील. सो नॉर्मल GD we have drawn on BE. So the path difference between GE and DI has to travel BC plus CD path. Meanwhile, this GE has traveled BG. So the total path difference between GE and DI is BC plus CD minus BG. पण इथं BC plus CD घेताना आपल्याला या थिन फिल्मचा रिफ्रॅक्टिव्ह इंडेक्स कन्सिडर करावा लागतो. So it is mu into BC plus CD minus BG. BG we have taken as it is because refractive index of air is 1. But when the ray gets reflected from denser medium, additional path difference of lambda by 2 is introduced, and therefore it is BG plus lambda by 2. Okay, so the total path difference is mu into BC plus CD minus BG plus lambda by 2. आता आपल्याला जर पाथ डिफरन्स फाइंड आउट करायचा आहे तर आपल्याला BC, CD आणि BG च्या व्हॅल्यूज फाइंड आउट करावे लागतील. सो we have to consider, let's find out BC and CD first. So let's consider triangle BFC and DFC. That triangle BFC मध्ये हा अँगल आहे हा R. So if you take cos R is FC by BC, and therefore BC is equal to FC upon cos R. FC is thickness, so T upon cos R. Similarly for CD is also FC upon cos R, it is equal to T upon cos R. Now next is BG. For BG you have to consider triangle BGD. In that triangle sin I is equal to BG upon BD. BD is the hypotenuse over here. So BG is equal to BD into sin I. BD is BF plus FD. Okay, but then we don't know BF and FD. Again you have to consider triangle BFC and DFC. आता ह्या ट्रायंगल मध्ये BF जर आपल्याला घ्यायचं असेल तर एकतर sin R घ्यावा लागेल किंवा tan R घ्यावा लागेल. ओके, सो इफ यू टेक tan R is equal to BF upon FC, and therefore BF is equal to FC into tan R. FC is thickness, so T into tan R, but tan R is sin R upon cos R. So BF is equal to FD is equal to T into sin R upon cos R. तर हे BF आणि FD ची व्हॅल्यू इथं BG च्या इक्वेशन मध्ये पुट केली तर BG is equal to 2 into BF plus FD. So 2 into T sin R upon cos R into sin I. This sin I. Now I want mu in this equation, so I just multiply and divide by sin R. So if you see this sin I upon sin R, this factor is nothing but refractive index. So it is 2 mu sin I by sin R, mu into T, sin R into sin R is sin square R upon cos R. Now let's put values of BG, BC and CD into this equation of path difference. So delta, that is path difference, is equal to BC plus CD is 2T cos R into mu. So 2 mu T upon cos R minus BG is 2 mu T sin square R upon cos R minus we have multiplied into the bracket minus lambda by 2. आता ह्या इक्वेशन मध्ये बघितलं तर 2 mu T upon cos R आपण कॉमन काढू शकतो. So we have taken it outside the bracket. Inside the bracket 1 minus sin square R. 1 minus sin square r is cos square r. So 1 cos r gets cancelled out, minus lambda by 2. So the path difference equation becomes 2 mu t cos r minus lambda by 2. And we know for interference, when this path difference is equal to n lambda, we get condition for bright. So here we have taken this 2 mu t cos r minus lambda by 2 equal to n lambda. आता हे लॅम्बडा बाय 2 आपण राईट हँड साइडला घेतलं तर n लॅम्बडा प्लस लॅम्बडा बाय 2 आपल्याला मिळेल. ओके, लॅम्बडा कॉमन काढलं तर n प्लस 1/2 लॅम्बडा बाय 2. We can take it as a plus minus 1/2 and therefore the equation becomes 2 mu t cos r equal to n plus minus 1/2 into lambda. This is the condition for bright or constructive interference. Similarly, for dark, what is the condition? Path difference is equal to n minus 1/2 into lambda. So if you put value of this n minus 1/2 lambda in path difference, we'll get the equation 2 mu t cos r is equal to n lambda. So condition for dark is 2 mu t cos r equal to n lambda. Here t is the thickness, mu is the refractive index, r angle of refraction, n order of interference, lambda is the wavelength of incident light. So these are the questions for practice. Difference between